Okay, this is Dr. Williamson, and here we have the titration data of acetic acid with sodium hydroxide. And one of the purposes of this titration data was to get the equivalence point, which is right in this region here, so we could find the endpoint of the titration. And the equivalence point occurs in this region right here. Kind of circle it. And it occurs right where this inflection point, where the slope changes direction. It's called the inflection point. Changes right where the slope changes direction is called the inflection point. And we can get it by eyeball if we do a best fit line or best fit curve. We kind of draw it in here like so. Kind of get our best fit curve. And then we yeah, then we kind of eyeball about where we think it is, and we can do pretty good. Like right about there, and then right about there. And that's pretty good. And that'll be the pH, and we can get a ruler out. We can calculate that. And that'll be the volume. Let's call that 18 milliliters. And then at half of this volume, so at 9 milliliters, I don't know, if I got a ruler out, I can figure out where the 9 milliliters is. I can go to the 9 milliliters. And at half of that volume, I can go right straight over and find out where pH equals pKa. And I told you guys later that that's going to be really useful information. But what if I want to get even more accurate than eyeballing this? Right? The larger I make this, the better I'll be able to do it. But if I want to get more accurate than eyeballing this, remember I told you it occurs right at the inflection point. And the inflection point is where the first derivative goes to basically, undefined or goes to infinity. And so what we want to do is, if I can move this entire graph, come on. This entire graph out of the way. Then I want to get rid of these annotation marks that are in Zoom. And what I want to calculate now, let's stop annotating. I want to calculate what's called a first derivative plot. And it's going to be a plot of pH versus volume. And the first derivative plot is going to be a plot of delta pH over delta volume. So let me change this here. Symbol. delta pH over delta volume, that'll be on the y-axis, versus volume. Now I'm just going to copy this volume here down. So I'm going to write equals A2. And then I'm going to go ahead and copy this all the way down. So I'm going to go Control B and copy it all the way down. But over here, to get delta pH over delta V, which is the first good approximation to the first derivative, I'm going to go this equals parentheses B3, which is 2.83, minus B2, close parentheses, divided by A3 minus A2, close parentheses. And that is the first derivative between these 2 points, or an approximation of the first derivative. Now I'm going to hit here, shift, down arrow, Control D for copy down. Okay, and I'm going to move this further out of the way for now. Now I'm going to plot this. This is a first derivative plot. So I'm going to go to Insert, Charts, Scatter Chart. And here is my first derivative plot. Now I've got two, I just see here, this is going to go up and this is going to go up to 0, but I don't need all of this and all of this. I'm just going to go from maybe 10 to maybe 15 to 25. Let me see what that looks like. 15, 25. Major is maybe 0.5. Let's see what that looks like. That's a little slanted. Maybe make that 10. Okay. Maybe make this a 1. Maybe go from 12 to 23. 12, 23. That might be good. I think that'll be okay. All right. And then this, I'm going to take this, move it over here. I want to make this as big as possible for you guys for now. There we go. Insert, axis title. Delta pH over delta V. I think I have my caps lock button on. Delta pH. Delta P. Oh no. All right, guys, I messed up today. Delta pH over delta V. This is, This is volume. Let's get rid of the title for now. And you're thinking, what do I do with this? All right, so we'll go annotate. And I'm going to do a best fit line. And there's a little bit of a judgment here. I think this goes something about like this. No, a little bit of judgment here. Okay, maybe something more like it's a little bit of judgment. This seems to go something, maybe this goes like this. Slope up like about there. And this seems to slope up about like there. All right, a little bit of a judgment call. And then I wonder if, then when if assuming that's correct, then my first derivative seems to be right about there. And I can get a more accurate number. Instead of 18, I can get 18 point whatever. And if I get a ruler out, I can measure, and I can measure where that line is, where that intersects, and I can get better numbers. Or if I just go here, let's see, get rid of the annotations. Here, copy. Go to File, New, here. I need to go annotate. Let me get rid of these lines here. Those don't need to be that. Okay, get rid of this. Stop annotating. Get rid of this. Come on, go away. Right? Go to Layout, Orientation, Landscape, Margins, 1/2 inch. Home, paste. Right? Come down here a little bit. And this first derivative plot, if I get a ruler out and I do this, it's whether you consider this dot right here to be part of this side, or you consider this dot to be part of this side, will change the 18 a little bit. Okay, so it'll change whether it's 18 point something or not. Okay, but just having the skill of being able to do a first derivative plot is going to be really, really helpful later for when you get into more senior level courses in chemistry or in engineering. Okay, guys, I just wanted to make sure you knew how to do that. So you could print this, get out your ruler, argue where you think this intersects best, drop a line down, and you would be able to call it not 18, but 18 point something, maybe one more significant figure or two more significant figures. Okay, guys? Anyway, just thought you'd want to know that, and I think it's really useful skill for you to have. Okay, then. I'll stop here. All right. Let me stop the recording.